Hello everyone, this video is about installing the NPAS in the KWA Tavor GBBR Airsoft rifle. Before we get into the install, I want to make clear that this design took a lot of time to get right. Several different options have been tried and tested. This is the only thing that works and can even improve consistency when also a few other aspects on the rifle are addressed. If you want this NPAS for your KWA Tavor, follow the instructions in the description below. Because we need to address several things on the rifle, this video can be quite long. It's important that you take your time and pay attention. Myself and other people with a bit more knowledge about the KWA systems keep getting the same questions again and again on what options are out there and what has been tried and tested to reduce the muzzle velocity. I will be going over these options, so this can be used for future reference. If you want to skip ahead to the install itself, look for the section in the video where I start talking about the required tools. Let's put this aside for now. Let's talk about the options. One of the first things that I tried in reducing the energy of this rifle was engineering custom flow restriction valves, otherwise known as FPS disks. So these kind of things. Yeah, these disks you put in front of the nozzle behind the rocket valve. There is one big downside of this, because the reason this method does not work is that you create pressure between the FPS disk and the rocket valve, and this buildup of pressure causes the valve to stay open longer and really inconsistent, so that is why it just does not work. The next thing that also does not work is the RA tag or the RATEG NPAS for the System 7, or in short the KWA system. Now, the reason that this thing does not work is because this body is too thick and this front end is too thick as well. If you drop one of these things in, your muzzle velocity can drop to 0.5 joules, making it just unplayable. Consistency with this thing can also be poor, so don't buy it, it's just not worth your money. What I've also tried was modifying the stock rocket valve with a piece of epoxy glued on the front to shim it further forward. This can work, but it is really difficult to get right. So let me just put this off. You need to know that this cross pin for the nozzle return spring is off center with where the rocket valve sits. And because that pin is offset, you need to make sure that when you apply a drop of epoxy, that epoxy is still in contact with that off-center cross pin. Yeah, when you apply a drop of epoxy on the front of this rocket valve, then you have to piece by piece remove that epoxy to get to the right setting. And you need to make sure that the flatness and the perpendicularity of that piece of epoxy remains true to the center axis of the valve. That is quite difficult to get right. If it's off just by a tiny bit, you can expect just massive inconsistency. Yeah, even after you get to the desired setting, you're still heavily dependent on the temperature changes. So a few degrees warmer and you shoot hot again. So that's the big downside of trying that. The last thing that has been tried and tested are these least precision FPS reducing valves. These were also fixed restrictions. These are the only things that actually work okay. Together with Gojira from the Heavy Recoil Club Discord group, I've taken over these dimensions and made small adaptations to the design to be able to make smaller adjustments in energy output. And I improved on two features as well. If you have access to a lathe, and you know how to work with such a machine, then I can share the files, because these, yeah, you can easily turn yourself on a lathe. If you're thinking about 3D printing these, forget it. That will likely not result in satisfying results, because the accuracy of a 3D printed machine is just poor. You might have to iterate a lot, yeah, to get it right, and to also have the shape nice and cylindrical, and that sort of thing. So I would not recommend 3D printing these with like a hobby FDM printer. With a lathe, you can get to the right tolerances, and yeah, that will work. but still these things are not ideal because you can't adjust them on the fly, and if you depending on the weather, still it can be the case that you shoot too hot on a warmer day, and then you have to swap these, and swapping these in the field is like a big no-no, because you need to bring too much tools and stuff. Yeah, it's just not really ideal. Yeah, so even with my own adaptation of these least precision FPS reducing valves, I was still not really satisfied with the result. So I started working on my own NPAS design. I wanted something that was adjustable, and this took a few iterations to get right. But the result of all this designing, making and testing, it took quite some time. It costed also a fair bit of money. But the wait is now over and I can finally get this to you. Let's get into the NPAS install itself. Just to be clear, this only works for the KWA Tavor. Other KWA systems are slightly different from the Tavor and will require a new design. I will be working on that. Again, for now, this is only for the Tavor. So the tools that you need, of course, a place to work on. You might need a bench block, something like this, a vise with soft jaws, so that you can clamp the nozzle. This has a leather surface, maybe a rubber surface will also work, but you want something so that you cannot damage the nozzle. A hammer, you need the right set of punches, so this is a 3mm punch, this is a 2mm punch, and this is a 1.3, 1.4mm punch. Now you see me pointing at drill bits. This is of course not the right tool to be using as a punch. It can even be a little bit dangerous, but this is what I have, and I have yet to invest in a proper punch set with the right size, with the right sizes. But it can work. Just know that it can be a little bit dangerous using drill bits as punches. You also need a hook tool, something like this. You will be needing a knife. And we will also be needing a deburring tool, something like this, maybe some needle files and some grinding stones that can also work. Probably forgetting something to list now, but you'll just see me using the tools as we go. You definitely need a 1.3mm hex key to adjust the NPAS. So that's definitely essential, and you also need some thick silicone grease, something like this. If you don't have all of these tools, then you might want to consider either buying them or improvising. I kind of trust that you can succeed in that. But the right size punches and the 1.3mm hex key is definitely essential for this. Yeah, let's have a look at the NPAS kit. I don't have everything completely here, but you will receive a package that has the NPAS, that has a spring, some O-rings, and a new nozzle rear piece. And this thing is really essential. You cannot live without this thing. And that makes up the NPAS kit. It will also include a bunch of O-rings. Yeah, but it will come with a bill of materials for reference that is also kind of self-explanatory as to which part is for what. The O-rings that will come in the NPAS kit, they will not be labeled, but you can measure them with like a set of calipers. This is also quite convenient to have. It doesn't have to be like an expensive Mitutoyo caliper. Something like this will be convenient to have. You can measure the dimensions of the O-ring and then figure out for where they go. I will also kind of explain that as we go along. Of all the O-rings, you will get 2. The rest, I think, is pretty self-explanatory, and some parts will also already come pre-assembled, like the O-rings on the new nozzle rear piece. Yeah, and the process of installing it all in detail, we of course will go over in detail starting now. So first, you take the bolt out of the KWA Tavor, you punch out that pin, rack the charging handle, and then the recoil spring and the bolt come out. I think that is pretty self-explanatory, so then you are left with this thing. You take a bench block or something, and you take your 3mm punch, and you punch out these 3 pins. After you've punched those 3 out, then you can remove the rear pin using a 2mm punch that out, and then you're just left with the nozzle. You can use the 3mm punch and press the rear nozzle piece out, and then the whole nozzle comes out. You have to take off this hardened steel block, and then you're only left with the nozzle. Now, why KWA decided to use 3 relatively big cross pins here in the hardened metal piece on the front of the bolt, I'm not sure. Just one is more than enough to keep that component in place. And I would also recommend just reinstalling the middle one as I have done here. Having all 3 in there is not necessary. It will just make the disassembly easier, and over time, if one of those holes just gets looser or the pin has deformed a little bit, you still have 2 other good holes left. So just reinstall only the middle pin. It's more than sufficient. Alright, then in order to separate the nozzle, you might want to place it in a vise or something. So for example, using your soft jaws in a vise, clamping it more or less like that, and then you can hammer out the cross pin that holds in the rear nozzle piece. Removing that pin can be quite challenging. You need to punch it out under the right angle. It is also tight in there. So if you don't hold it firm enough, then you will lose the hammering energy, and removing that pin might seem impossible. So clamp it down tight in something with soft jaws. Don't damage it, don't damage these surfaces. Try to prevent that at all costs, and hammer that out. Maybe you have like a different bench block and you are able to constrain it better. Maybe that also works for you. But punching it out under the right angle with the right size punch is really essential to be able to remove that pin. If it moves while you are trying to punch it out, you will lose all the energy in the right direction, and taking that pin out will really seem difficult. But if you manage to get that pin out, you can separate the nozzle. I suggest then using like a hook tool or something. Do not poke into the O-ring, but just poke behind it and then just separate it. Now you can take the rocket valve and the spring out, and before we go into installing the NPAS, I would like to go over some aspects of the bolt first. The bolt can have some casting defects. I can better show you that on this example. And the most problematic casting defect can be inside here where the nozzle goes up and down. Those casting defects I have found mostly on the bottom. This roughness inside here can lead to small leaks. It can cause a little bit of efficiency loss and some inconsistency. Depending on how much your rifle is used, this roughness might have been polished a little bit. If your rifle is still relatively new, I would suggest to clean the bore and feel with your finger if you can feel out of the ordinary roughness. If you feel burrs or something like that, you might want to use some 1000 grit sandpaper or maybe some circular grinding stone and just lightly polish that roughness a little bit. Don't overdo it. Don't sand it out completely. That would be a mistake. Some thick silicone grease like this stuff can fill that roughness, and else you just have to deal with it not being perfect. You do not want to increase the bore size or make it unround by unequal sanding. That would be a big mistake to do so please don't. The next thing that you might want to modify on the bolt are all these sharp edges. So this is a casted product that has been post-processed on a milling machine and then coated, but it has a lot of sharp edges, especially these edges here on the inside that can cause damage to the O-ring of the nozzle, and it can also damage the inside of the rifle's body. So you might want to make that not sharp anymore. Yeah, so I would suggest just cleaning the bolt completely. You don't have to get it into this state. You can just leave the return spring rod or the piston, you can just leave that attached, but this is just for, you know, showing it to you. Deburring all those edges, that can be done with either needle files or a deburring tool. So if we look at my backup bolt, all these exterior edges, everything is deburred. As you can see, all the lighter colored edges are all deburred. So every edge that either contacts the body or the nozzle, those have all been deburred. You don't want to overdo it. It's convenient to do it with the deburring tool like this. It can also be done with a different kind of tool that more or less serves the same purpose. But you don't want to over deburr the edges, but deburring it will just make sure that it just runs a little bit nicer and that you cannot damage the O-ring anymore and you don't scratch up the internals of the body. So that is kind of how it looks. I hope it shows up on camera all right. But just go over all the edges. That's it. So now that we've covered the bolt and you did all that deburring and you cleaned it again thoroughly, then you might want to grab some thick silicone oil, something like this, and then just put a little bit inside and just distribute that around with your finger so that you apply a light coat all around, and that is sufficient to have greased the inside and fill up a little bit of that roughness that is in there. Alright, so we will be placing this aside for now. Now back to the nozzle. The stock rocket valve, grab it, place it aside. We will not be needing that anymore. The rocket valve spring, this is what we will be using again, and it should look like this. So I hope it's clear enough on camera, but if it looks any different than this, you do not have the right spring. It needs to be the stock spring, because if it's anything else but the stock spring, it will have different properties. The spring stiffness will have an effect on the functioning of the nozzle. It will also affect how the end pass will work. So if you decide on using the wrong spring, then expect different results from the end pass. Use only the stock spring that comes with the nozzle, and that should look like this. Yeah, the nozzle return spring with the nozzle return spring plug, that is what we will be reusing. Just note that these two that I have laying around here are for different KWA rifles. This one is for an LM4, I believe. This was sent to me wrong at some point, but we will be using this for the example of installing all of this. And this is from the KWA Vector. The only difference is that the end geometry, that is different. The rest is all the same across all the KWA platforms it seems. Or at least the ones that I have here, the LM4, the Vector and the Tavor. The stock nozzle return spring, this thing, we will not be reusing. And the rubber overmolding we will replace. That is quite important. The nozzle return spring can be modified to work with the end pass, but I will include a new spring with the end pass kit. That is just easier to install. This new spring is a little stiffer than the original spring, even though it has the same dimensions. The length is a little bit shorter. I also tested with this new spring and it doesn't seem to affect performance in any way. Just know that the nozzle will return a little bit faster because this is just a little bit stronger. Doesn't affect performance, so it's good. Then the rubber overmolding on these plugs, we will be replacing. Over time this rubber becomes really brittle. It will just start breaking away on its own. It also will not work with the new nozzle rear piece. So we need to replace that with a standard O-ring that comes with the end pass kit. And I will show how we're going to do that. But first, we're going to take the nozzle return spring off. And this will be a little bit of a bitch to do because the pin is really small and it's difficult to hold on to. I've already tried several things and right now I'm going to try and remove it by putting it in my bench block that has a 6mm hole that this thing fits snugly in, and I hope I can hammer the pin out. So we're going to try that. You can also try to lay it over like a 10mm hole like this, and then try to hammer it out, or you can even try to use some soft jaws, some aluminum soft jaws with like a V-groove and clamp it in there. That'll also work, and I might even need to do this because this is the first time I'm going to try to do it like this. Punch it out, hopefully it stays in place. No, that will not work, so I have to do that off camera. This trick might work with the longer end of the Tavor rear nozzle piece, but it does not. This trick does not work for the LM4 nozzle. So I have to clamp this in my vise, then hammer it out, and then we'll continue. So for this I'm going to use these soft jaws. Alright, so that pin is out. You want to keep this spring somewhere. Don't lose it, because you can modify this to work with the new NPAS kit. But as I told you, I've included a new spring that is already to the right length, and that will just be easier to install. This is actually one of the springs that is original to the Tavor that I have modified myself to work as well, but I might go over that in a different video. So just take your spring and just place it aside, but store it somewhere safe so that you might be able to use that in the future. Right now we're going to remove the rubber overmolding from this nozzle plug. So you might want to take a knife and make a gentle cut in the rubber. Try not to damage any of the surfaces. You want to prevent that from happening. Just push it all the way down, and then this rubber will just start to break away. You can use the hook tool, for example, to just push all the rubber off. It will probably break off in like all these tiny pieces, and just be careful that when you're doing this you're not really pushing hard against any of the surfaces. You don't want to make scratches, just try to prevent that. Just gently scrape everything off. And just make sure that it's clean. A brush can also be handy. Right, I still see that I have some residue left, so I'm going to remove that as well. Alright, just brush all the tiny remaining pieces off, and then you're left with this. Now all this debris, and you've probably experienced that this rubber is also really brittle. Now again, over time this will happen naturally. It will break away, it will fail. It's also really hard rubber, and we will just be replacing that with an O-ring from the kit. Before we're going to put the O-ring on here, and I will explain a little bit later why we are doing this, but before we put the O-ring on, we need to deburr these edges. These edges can be really sharp, it can damage the O-ring, so we want to deburr that. We also want to apply a small chamfer to this top surface for the new spring, so that you can easily reinstall that spring later. And we will start with that. So I'm going to take one of my needle files, and I will make a chamfer here. And I'll just go ahead and place this in the vise, and then make a small chamfer here about 0.5 millimeters in width, and at about a 45-degree angle. So just bear with me and let me do this. just like that, and I hope I can get this. Yeah, that'll show up on camera. Alright, and then for all the other sharp surfaces, you can also just continue with your needle file, for example, but you don't want to overdo this, so you can also just use like a grinding stone or something like that. Maybe even some very fine sandpaper, but with sandpaper you're likely scratching up the surfaces too much. So you want to deburr and polish all these small edges, just so that they're not sharp anymore and they cannot cut into the O-ring. Now this of course will take some time, but just take your time, be patient, and do it right. Because if you end up with damaged O-rings, you have to source one of those O-rings yourself. But you will get two in the kit, so if you fuck up one, then you do have a spare one. And the key is just to not overdo this. It just needs to lose that sharp edge. And that's it. Now also for this side. Alright, so just feel with your finger. Go over the places that might need a little bit more attention. Yeah, that feels about right. And now you also want to deburr these two edges where we will be placing the O-ring. You can just go over them like that. And this will just take that sharpness off. So just like that. Now if your nozzle plug is really greasy or dirty or whatever, then you might now want to clean it with some isopropyl alcohol. Also make sure that there is no debris left on the O-ring on the rear side here. I have also included four additional O-rings for this nozzle rear piece. 2 times 2 O-rings, because they're in different, slightly different sizes, so one might seal better than the other one. So if you also have like a damaged O-ring there, then you have 4 spare ones to play with. Yeah, so now it's all deburred, and I hope I can kind of show it on camera. Lighting is not ideal, but yeah. Those sharp edges have been deburred, and we have now a less likely chance that the O-ring gets damaged on those sharp edges. What we're going to do right now is find the O-ring in the kit that measures 3.3 times 2.5 millimeters. So that's this O-ring. And you can just measure this out with calipers, 2.5. And the inside diameter is 3.3. This O-ring needs to go on there for some reasons. I will explain shortly, but it will need to fit just right in here with the O-ring. Because of 3D printed tolerances on this nozzle rear piece, it can be the case that this O-ring is not the ideal size to put on the plug. Unfortunately, that's just how it works out, tolerances, etc. So I have included one additional size with the kit. Those are these, 3.6 times 2.4 millimeters. that you can also try. That might be a better fit, it just depends on how this turns out. But yeah, after having several of these 3D printed, I've found out that these two sizes work equally well, but you might need to do some fine tuning in the order of using some 3M black duct tape and place just one layer around the inner diameter right there. But I'll show you how that turns out. There are many different O-ring sizes out there, and I've tested all the available O-ring sizes that are out there, but unfortunately the most ideal O-ring size, that is 3.4 times 2.5 or 3.5 times 2.5 millimeters, those two don't exist. So yeah, we might have to tune it a little bit with some tape to get it right. There's just simply no other option. Yeah, no worries, the tape will be underneath there, so the O-ring will keep the tape into place, so you absolutely don't have to worry about ever that tape comes out. So yeah, this is also where the hook tools come in handy for placing and removing the O-rings. So you might need one or two. I will probably be using two, especially for the removal. We can place this thing aside, we are not going to use that anymore. But you will need to keep this cross pin that comes from the original nozzle. We need that shortly, but the rest you can just put aside. Alright, now also this thing I already prefabricated. So this I will also show as an example, but let's just continue with this. So we're going to put this O-ring on the plug and we'll just see how it's going to turn out. It goes on there a little tight. It might be a little bit annoying to get this on. Yeah. Right. And then just push it home. Alright. So now that it's on there, we're going to grab the rear nozzle piece that comes with the NPAS. And as you can see, this is a 3D printed part that has been fully post-processed and also test fitted to make sure that it will be a drop-in fit. Yeah, all the holes are post-processed to size. The 9 times 1 millimeter O-ring has been pre-installed. Yeah, the groove that it sits in has been post-processed by hand. The end is vented to help creating a better seal. The end O-ring groove has also been post-processed on a lathe to get all the dimensions to spec and also have it sealed properly. The right size O-ring has been installed. This will probably be a 14 times 2.5 millimeter O-ring. In the kit you will also find some spare O-rings, which you will all get 2 of, that have just slightly different sizes that can help in creating the most ideal seal into the bolt without encountering friction. So that's that. Yeah, and it will also just look like this. The end can be cleaned up a little bit. Yeah, but all that post-processing is absolutely essential to create proper seal surfaces here to make it all to spec. 3D printing is great for these kind of parts, but it's just not always that accurate. So post-processing is always required, but I will do all that for you. 3D printing is just great for the general shape, but in order to make it to the exact specifications that this part needs to conform to, I have to do several things in order to make it just right. So I actually take these to a lathe and make it to size and make that groove for the O-ring exactly to spec. That's really important. You do not have to worry about the strength of the material. I have tested this all thoroughly. The 3D printed nylon material with the multi-jet fusion process that I've used for this is more than strong enough, and I did not experience any failures on this part so far. So it's more than capable enough, and it will last you probably forever. Alright, so the next thing we're going to do is to check the position of the plug with the O-ring with respect to each other. So the reason why we might need to fine-tune this is because we want to eliminate all the variances, all the tolerance variances, and just make it exactly right. Take the two pieces and just put it into each other. And right now the nozzle plug, so this piece, should not protrude more than 0.2 to 0.4 millimeters from the rear. If it sticks out more, the nozzle will eventually sit too far forward in the rifle. When the nozzle plug sticks out around 0.2 to 0.4 millimeters and you press on the rear of the plug, then you will see that you are able to push it flush with the rear of the nozzle, and it should not take too much force to do so. If it already sits flush with the rear end or lays a bit inside the hole, then we either need to install a different size O-ring or apply one layer of this thick tape to shim the O-ring out and make the rear nozzle plug just stick out just the exact right amount. As we can see right now, and I hope I can get this on camera, it already sits flush or maybe even a little bit below the surface. So we want this. So this thing I already built to spec. We want it to stick out just a little bit, and if I apply a little bit of force, then I can push it flush with the rear. Now that is what we want. Now in order to measure this, you can take, for example, a 0.3 millimeter shim that you use for shimming gears in an AEG. You can lay that on there and then just eyeball the height of the nozzle plug. If it's around the same height as the 0.3 millimeter shim, you're good. If it sticks out way more, then it's too much. And if it sits way below that or even below the surface of the nozzle rear piece, then you will need to put a layer of tape around that inner diameter of the plug. And I will also show you how to do that with this thing. So we're going to take our hook tools, and we do not want to poke into the O-ring because we do not want to damage the O-ring, but we want to grab under it. And this might be a little bit challenging. All right. Yeah, like that. Then maybe also use this one. And then we want to try to pull the O-ring off. Try not to overstretch the O-ring too much. And like that, the O-ring comes off. Now we're going to grab a piece of tape, either measure it out or just eyeball it. The last time I also eyeballed this, so we'll just see how we do on the first try. Something like that. And just take that little bit of tape. It needs to fit exactly in the width of that slot, and then just push it all around. Just like that. Then I see that I have a little bit of excess and I can just cut that away. Take my tool again. And this is pretty much exactly one revolution around that inner diameter, and that's perfect. Now I should have probably grabbed a little bit of a fresher piece of tape or degreased everything properly before doing this, but this is just an example. Then You take your O-ring and you push that O-ring back over it again. And now it really doesn't help that the tape does not want to stick. Make sure that it does, it will make your life a lot easier. And then just push the O-ring home again. Like that. Now, then we're going to take our nozzle rear piece again and we're going to compare the results. And right now it's perfect. So if I now also place the 0.3mm shim besides it, I can see that it has about the same height. And if I push lightly on the end, I can see that I can push it flush with the outer surface of the rear nozzle piece, and that is just spot on. Alright, nice. Of course, you do not have to exactly use this kind of tape. You can experiment with other tapes as well, as long as you kind of reach the desired height of the plug sticking out from the rear end of the nozzle. But this 3M black duct tape, I believe you can get all around the world, so it's pretty universal. The whole reason for replacing the hard rubber on that nozzle plug is because of what we've already gone over. It will fail eventually, it will become brittle over time, it will break away on its own. So it's better to replace it. You need to replace it in order to make the whole NPAS kit work. So this is a mandatory modification. But the actual reason for a piece of rubber being on this plug is not for sealing. It is in place so that when the nozzle retracts in the bolt, that the nozzle gets buffered a little bit. So the O-ring is able to absorb the returning motion of the nozzle, buffering it out, not causing bounce in there. That's the purpose. Yeah, and it can also, when the whole bolt goes into battery again, it can also absorb a little bit of that force that is being transferred from the nozzle to the rear of the bolt again. That's its purpose. It's not for sealing, it's to absorb force. Now that we've covered that, we can install the new nozzle return spring into the nozzle plug. Yeah, this can also be a little bit challenging because the pin is really small. Yeah, and we do not want to damage the eyes on the spring. So we need to be patient with this and take our time to do it right. So what we're going to do is we're going to get the pin started on the hole and then hammer it home just far enough so that the eye of the spring can just fit in between the pin and the slot of the plug. And then we need to make sure that the pin will clear the eye, and then we can hammer the pin fully home. If the pin gets stuck on the eye, you need to be careful with that because you do not want to damage this spring. These springs are relatively expensive, and if I have to ship you a new one because you fucked up the install, it's your problem. Take your time, check it, and just don't mess up because that would just be a shame. Yeah, let's see if we can show this a little bit here on the bench. Might be a bit difficult because this pin is really small. Yeah, so now I'm looking for the place where I previously put my punch to punch the pin out, and I want to keep hammering on that same surface. Yeah, this might be a little bit difficult. Let's just test fit if it will clear that. Just about. And right now I've gone just a little bit too far, so I have to hammer it back out just a little bit. I felt it move. Yeah, and right now I think I have to place it in a vise in order to proceed. I can try if I can make it work like this, but it might be a little bit difficult. Now the spring will sit really closely to the front surface of the nozzle plug. That is just how it is. The eyes are a little bit closer to the main body of the spring as with the original nozzle return spring. That's why you really need to take your time so that the pin doesn't hit the eye. That's kind of the difficulty here, and that is also why we chamfered these front edges about 0.5 millimeters with a 45-degree angle, so that we can make this all a little bit easier to reinstall again. But still, you need to take your time because you just don't want to fuck this up. And it might be more convenient to place this in my vise. Yeah, I will just try to do this in the vise where I can properly clamp this and still be able to hold this, because yeah, this is just probably the most difficult aspect of the install. Alright, so that took a little patience, but it's now in there. A nice tip that I can give: if the eye is not clearing the pin by default, I do not recommend that you stretch out this eye in order to make it work. Don't do that, please don't. You might fatigue the eye, causing it to break sooner than you might want. What you can do is hammer the pin into the plug so that you can just barely push the eye of the spring past the pin, and then use your hook tool from the other side and force that eye down just a little bit, and then you can hammer the pin home, and then it'll clear the eye of the spring, and then the install will be successful. Again, take your time, don't rush it. If you fuck it up, it'll be an expensive replacement. Right now we're going to install this assembly that we've just made into the nozzle rear piece. So for that we need the original cross pin that is from the original nozzle. We're going to get this started in the rear hole and just push it in about halfway. Then take the nozzle. Also make sure that when you are hammering this pin back in, to make sure that the pin is centered. That is quite important. You do not want to having it stick out to one side, because that will scratch up the internal bore of the new nozzle rear piece. You don't want that. So now just push it in. Eyeball the orientation of the eye of that spring. Keep this in place. And then take your hook tool and try to find the eye of the spring. Might want to clean that a little bit more. Yeah. So now I have I just lost it. Yeah, I've got it again. And try to hold it over, yeah, try to just push it over the crosspin and push the crosspin flat with both sides. Now make sure that the spring is in the center of that crosspin. It has a small groove there. Make sure that you slide it in place. And now comes the other part of the end pass, the actual adjustable valve. That's this. It comes with a new crosspin. And yeah, this crosspin comes with a kit. This is a hardened 2mm H6 parallel pin. This has been cut and grounded to length from a 12mm pin to a 10mm pin, just so that we have maximum surface engagement with the nozzle. That's kind of important, so this is a custom cut to size part. This pin, this is where the end pass makes contact with. So now grab the end pass. This is also a fully this one is also fully post-processed already and has the M2.5 times 6mm set screw already installed. And I've let it stick out about 1mm. And you will figure out on, yeah, also depending on your setup, what kind of joules you will be getting from that. Because I cannot tell that, you will just, you will find it out by yourself. But you can either screw it in a little bit more or screw it out a little bit further. If you turn it clockwise, then you will reduce the energy output. And if you turn it counterclockwise, you will increase the energy output. The total adjustment range depends on your setup, but believe me, it's more than enough to get this in the range of 1.2 joules, for example, even well below that, probably still up to about 1.7. I'm not really sure, it just depends on your setup and the kind of gas that you're using. It's also a 3D printed part. This is of course because of the complex geometry. Yeah, this is also the most cost-effective way of producing it. There are no significant stresses on this part, so therefore SLS 3D printed nylon material is more than sufficient. The reason this is SLS printed and not multi-jet fusion printed is because SLS is more capable of making small parts with the right amount of details. I've included a small groove for the spring to sit in. And it also has like fins, like the original rocket valve, to help it stabilize. You can test fit this once in the rear piece like this, and that should not have any weird resistance, because I will test fit and post-process this all so that this is already perfect. Now you can also take that pin and just put the pin into position. Yeah, make sure that it is centered, and the end pass, the valve slides underneath here. You can test fit that. Again, it should not have any resistance. So that's kind of the whole thing in order to make this possible. And you can right now leave that just sitting like this. Take your spring, push it over, take your nozzle, and mate the two together. Don't just force it home. You might fuck up the rocket valve spring, so don't do that. You might want to use a tool or something to help and guide that spring into place. And you can verify that that is going correctly by looking into the inlet of the gas and then just slowly push it home. You also might want to put a little bit of that thick silicone grease, stuff like that, on that O-ring, and it can also be a good idea to lightly grease the O-ring on the back end of the nozzle so that everything is nicely lubricated before you install it into your bolt. So now just carefully push that together, and right now the install is pretty much complete. So we're going to check the movement of the valve in the nozzle. It should move without any resistance or slipstick behavior, and if you verify that this is sliding up and down without any problems, then we're good. Now you can reinstall that pin the same way we kind of put it out, put it in some soft jaws and carefully hammer the pin back in. Make sure that when you hammer the pin back in, it does not stick out of the exterior or the outside diameter of the nozzle. That would be problematic. So make sure that it is nice and centered in there. And then reinstall everything back into the bolt. Put the hardened metal nozzle stop back into place. Yeah, reinstall the pin and reinstall the smaller pin here on the end. And then the install is complete. You can put it in your rifle and just do some test shots and see how it works. With the 1.3 millimeter hex key that you have to source yourself, you can then easily put it into the body and then just make some adjustments. Now this of course will go with some resistance, and that all has to do with that the set screw is by just having it self-tap itself into place. So it is in there with plenty resistance, so you absolutely don't have to worry about it self-adjusting. The friction is just too high. So once you set it, it will not move on its own, it just can't. If you turn it clockwise, then you're decreasing the amount of energy that comes out of this thing, and if you turn it counterclockwise, then you're increasing the muzzle velocity or the muzzle energy. That's it. Now, I hope that has all been clear enough. If you think something is missing or whatever, then just comment section below, or write me a message via the Heavy Recoil Club Discord group or in a private message. Then we can talk about it. Maybe then I will add some more comments down below to maybe explain a few things a little bit more, but I hope I have been clear enough, and this video is already becoming quite long, but we're still not really done yet, because there are 3 more things we can talk about in order to make this thing perform even better. So the first thing that you might want to look out for are the length of the screws right here next to the injection port. So this screw, there are also 2 screws underneath this block, underneath the brass deflector, and also here. Now these 5 screws can be too long, and by being too long they will sit on the inside of the body and they will scratch up your bolt. Now this can lead to inconsistency, performance loss. So you don't want that. You can check for that easily just by looking into the rear end of the rifle, into the inside of the body, to see if they stick out a little bit or not. Now by either use, this can already have worn in a little bit, but if you see them sticking out, just take them out and use like a Dremel or a file to reduce the length just enough so that the bolt can move without interfering with those screws. You don't want to overcompensate that, because the thread engagement of these screws into the body is already kind of low. So you want to keep the screws just long enough so that it doesn't hinder with the operation of the bolt. Second is the magazine. Now on my Tavor, the magazines, they set about 0.4 millimeter too low. In the past, before I modified this caused really poor performance, fast cooldown, also poor consistency. And in order to fix that, I glued a piece of plastic into the mag catch hole of the magazine. And this can greatly boost performance and consistency. And I highly recommend checking this, because this solved a lot of the issues that I initially had with this thing. Might want to show this a little bit more a little bit better on camera. So here you can see that small ridge right there. Lighting is not ideal, I know. And that piece of plastic makes sure that the magazine touches against the nozzle just right so that it seals off properly. Now, depending on your rifle, this modification might not be necessary at all. So it just depends. It might be less than 0.4 millimeters, but more than 0.5 millimeters would kind of be weird, because then the tolerances are really large. But in order to check what you need, first put the magazine in the mag well and just then push up and down. Now, in my case, all the play has been removed, but in your case, if you push it up and down, left and right, you might feel movement, and that is kind of a dead giveaway that you need a little bit of adjustment. And depending on how much you need, you just have to figure out. But what I can recommend doing is take a piece of hard plastic, put that in there without permanently fixing it, and then just check, kind of how much you need, readjust from there. I will also show how we can do this. To start with, a piece of 0.3 millimeter thick plastic, that would be like a good option to figure out how much you need. As I said, just place it in the window without permanently fixing it. Maybe you can also try use a piece of tape at first, but eventually you do need a hard plastic insert in that place. What you can then also try to kind of figure it out is just place your magazine into the mag well, push in the magazine release, and if you then push the magazine lightly against the bolt and release the magazine release, if it automatically falls into place, then and you still have some play left, you might want to adjust with 0.1 millimeters and then retry, because what you want is to have the magazine catch just stay onto the magazine, and then when you apply a light bit of pressure, it falls into place. That is what you want. Then you've eliminated all the unnecessary play that might be in there, and then you might want to make that fix permanent on all your mags. Now again, how you can check that is just by putting a piece of plastic or tape into that small section on the top here. Place your magazine in the mag well, push the magazine release, push it in, press this lightly against the bolt, release. If it then requires a little bit more force to let that thing snap into place, then you're good. Now, in my case, this was about 0.4 millimeters. Don't overdo it. If it really requires a lot of force for the magazine to seat, then you've overdone it and you can experience some cycling issues. So it's better to have it a little bit, to have it, exactly right or a little bit below that, than applying a too thick piece of plastic so that it hinders proper cycling of the rifle. To make this modification and have it last, follow the following steps. This piece of plastic that I've glued into here was taken from a hard piece of packaging, something like this. Make sure that the plastic is PET or PS. If it is PP or PE, it will not glue right and it will easily fall off. Usually you can find a material stamp on the packaging. For me, that is situated right here, and it says PET. I cannot show this on camera, it's just too difficult because of the transparency and the lighting that I have here. But this reads PET, and PET material or PS material, that will glue properly with the glue that we will be using. But polymers like PE or PE will just not glue right. It's just inherent to the material, but also a lot of packaging material can be polypropylene or polyethylene, and polypropylene and polyethylene will just not glue right. So PET or PS, polystyrene, that will make sure that the bond that we will be creating will last. Yeah, so what we will do first is take the magazine, and then we're going to take some isopropyl alcohol, some IPA alcohol, cleaning alcohol, and we're going to decrease that inner edge. After we've done that, we can take like a needle file or maybe some sandpaper, let me grab some sandpaper. Yeah, some sandpaper, 240 grit for example. And then just rough up that inside just a little bit. Don't overdo it, it just needs to be roughed up a little bit. After that, you clean again with isopropyl alcohol, and then you have a clean and roughed up surface. After that, you can place the magazine aside. Then you take a piece of this hard plastic. So let me just cut a little piece off. Just like that. And then you're going to measure out how much you need in order to glue this in the window. Just use your calipers, measure it out, and then transfer those dimensions to the piece that you will be cutting out. I will just be demonstrating this. And of course, the piece that you're cutting needs to be nice and rectangular, but if it's just a little bit oversized, sense of the height, that's not a problem, because after we've glued it into place, we can cut that away. Measure it out, cut it nicely to size, and then we're going to decrease this piece again with isopropyl alcohol. We completely clean it, so both sides. And then we're going to take our 240 grit sandpaper. So let me just illustrate this. So we're going to take a piece of sandpaper, put it on the hard surface, and sand just one side. Now this is a little bit annoying to do because the piece is quite small, and of course you will sand also your finger a little bit, but yeah, that's not really that problematic. Just rough up one surface, go into circles, back and forward, left, right, and then we have one surface that should be evenly dull and roughed up. Right now that is still not the case for this piece of plastic, so let's just make this right. There is no use in sanding both sides because only one side will get glued. Alright, and now the piece is evenly dull, evenly sanded. Then again we're going to clean this with isopropyl alcohol, so we're just going to clean that. And then we have a cleaned and roughed up magazine catch surface, and we have a cleaned and roughed up hard piece of plastic that we'll be gluing into that place. It is essential that you follow these steps exactly in the order as I have explained in order to make a proper glue connection. Now after cleaning this and having cleaned that, you might or you need to wait about 5 to 10 minutes in order for all the alcohol to evaporate out of the material. Else it can still affect the glue connection. And you want it to be kind of permanent and really glue well, because if you have it fall off like mid-game, that would kind of suck. So that is why these cleaning, sanding, cleaning action is absolutely essential. But then after the wait is over, you can grab some tweezers. You can grab it in the middle of the piece that you have prepared. Make sure that you have the roughed up surface on the right side, and then you're going to grab Loctite 401. Let me just grab that real quick. So now grab this kind of glue or source this type of glue. You can also use a different kind of fast curing glue or seconds glue or whatever you want to call it. It's a CA glue, cyanoacrylate glue. This is also what I use professionally very often. It's just the go-to all-arounder. If you can source this will also work, the 406. This is more tailored to glue specifically polymers, but this is just the all-rounder. I would suggest using this. This one is thin like water. This one is just a little bit thicker. It's more easier to work with. So I would just recommend using this one. Take the Loctite, apply a small drop on that surface. You might need to distribute that around with, for example, your hook tool or something like that. And then you're going to take your magazine and you're going to angle this piece into place. So you're going to place it like that, push it forward. I might want to show this on camera a little bit, but of course you keep the tweezer upright. Then you're going to angle it into place, and then you're going to take a second tool, maybe your hook tool or something, or a what do I have here? Maybe like a tiny screwdriver or something like that, so that you can push that plastic piece for about 30 seconds to 1 minute against the surface of the magazine in order to achieve initial cure. That's really important because you need to press out all the excess glue and make sure that the curing has initiated, so that after about 30 seconds to a minute you can let go and you can leave it to cure for at least 4 hours. I would recommend leaving it just alone for 4 hours. If you then have some excess height of the plastic sticking out, you can use a knife to cut that away. Don't cut in this direction because then you put force on the glue connection, but try to cut in this direction towards the glue so that you don't peel it off. It shouldn't happen, but just be sure that you're cutting it away from the right direction. All right. And of course, after it's cured for about 4 hours, then you can test fit it again in the rifle to see how it functions. And then it should be either, just like how I showed you, or pretty much all the play should be gone. But again, if it feels like you have to really force the magazine in there, take it off again, reduce it with 1/10 of a millimeter and then just retry. That is really essential. You do not have to worry about glue creeping under polymer shell and gluing the polymer shell to the metal gas tank. You don't have to worry about that. The amount of glue that will creep under there is not a lot, and if you want to remove the gas tank from the polymer shell, then that glue that might have creeped under there will just easily shear away. So don't worry about that. You don't have to take the polymer shell from the gas tank in order to do this. It's just way more convenient to do it as I've just shown you. The tiny little bit of glue that creeps under there is just not something to worry about. Now lastly, the barrel and Hopup. So the barrel and Hopup of this thing. As pretty much all of you know, the standard Hopup design for the LM4 and for the Vector that's also hanging on my wall here, but also for the Tavor, that design is just absolute shit. There is no other way to describe it as to being just a shit design. It's flawed, it is stupid, and I really don't understand why KWA realized that sooner and just made a much more regular design like VFC did, for example. That would have been much more convenient. Unfortunately, KWA stuck with this design for a long time. I have seen for the LM4D that it is different, but I've also heard that it was not that great, but I just don't have any hands-on experiences with that. And also for the AUG, the F90, I'm not sure, but I also still believe it's suboptimal. But no hands-on experience, so don't hold it against me. How does the Hopup adjustment work? You put the bolt to the rear, and then you have that special tool that comes in the box when you buy one of these, and then you adjust the castle nut on the Hopup up and down in order to increase or decrease hop. But this is a flawed design, and it simply just doesn't work. What you're doing is you're pressing a copper leaf spring into the bucking by rotating that castle nut. But that way of adjustment just doesn't work. So what I have done, and I will probably make a separate video on this at some point because the video is already really long, but I made a TDC mod. Yeah, this TDC mod that I made, I also made years ago already for the KWA Factor, and that has worked absolutely great. But without access to a milling machine, it's impossible to do, because you need to drill it at exactly the right position, exactly centered, exactly at the right position, because if it's ever so slightly off, the BBs will either fly to one side. That's really important. But yeah, I will kind of show how I did that in a separate video. But without access to a milling machine, that modification cannot be done. It really needs to be exactly spot on for it to work right. You also need a upgrade kit from Maple Leaf, a new sleeve and a new bucking for the KWA specifically in order to make the right combination of parts and modifications. But yeah, a separate video. Yeah, there are two other options out there that you can buy in order to improve on the shooting performance, and that is the Shoot Happy Armory Hopup. That's one. It is a one-piece design that makes a TDC adjustment possible, kind of like I did, but then it's just a completely new part. Sourcing this might be a little bit challenging, and I have not checked in a while. But also the Shoot Happy Armory one, I'm not exactly sure if it uses like a rubber piece that pushes into the bucking. But the way that I made my modification, I think is better than the Shoot Happy Armory modification, but separate video, we'll talk about it then. The other thing that is out there, that is the TNT Hopup and Barrel Kit. I have one here that I also installed previously in this thing, but because initially the performance of my rifle was kind of poor because I had to do this modification, I took it out and I made that TDC modification and reinstalled the old barrel and the old Hopup. That's also what's currently in here. Yeah, so I have very little experience with the TNT Hopup and Barrel Kit, so I am unable to tell you if it is worth buying. Maybe others can tell you that. What I can do is criticize on the design of the TNT, but without further testing it myself. It's just speculation, and then I don't like that. That is kind of a drop-in thing that works. But yeah, maybe others can tell you if that's something that you might want to consider buying. For now, that's it for the video. Sorry for it being so long, but I have to be fully complete and also clear about how you want to do this in order to install it right and also kind of boost performance of this thing a little bit. If you think like I have missed anything, then write a comment in the comment section below or find me on Discord. Look for my name, Spartan. You should easily be able to find it in the KWA Tavor section on the Heavy Recoil Club Discord group. So head over there. If you want this NPAS for your rifle, then follow the instructions below. And thank you for watching, and I'll see you in the next one.